Hello, 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 hello. Hi, everyone. We're going to go ahead and start off with our group work for today. Okay. Find the arc length of f of x being this function on 1 to 5. Don't evaluate because we're going to get like a weird power within it. Okay. So the formula for this is a to b square root of 1 plus f prime of x squared dx. So I'm going to go ahead and just figure this out on the side so it's easier for me to plug in. Go ahead and do the derivative. We get a 3 square root of x minus 1. And then we're going to go ahead and square the whole thing, and we get 9 times x minus 1. And that's going to get 9x minus 9. Okay? So now we have that whole expression. We can plug it in. Let's go ahead and just start from here. It says from 1 to 5, 1, 5, square root of 1 plus 9x minus 9 dx. The inside of that can simplify to -8. We're going to do u substitution. Du is then 9. Oh, sorry. Dx. There's not a 9 here. That's like a multiplying factor. So it's best if we just divide it out. And we're left with going too fast. 1 over 9 integral 1 to 5 square root of u du. Plugging this back in, we got u 3 over 2 over 3 over 2. And then we're going to go ahead and take out that fraction to be 2 over 27 u 3 over 2. Oh, all from 5 to 1, 5 to 1. Then I'm going to plug in back x. Five to 1. And then let's go ahead and get that out. At 5, 9 times 5 is 45, minus 8 is 37. So 2 over 27, it's going to be 37 to the power of 3 over 2. And then 1, 9 minus 8 is just going to be 1. So minus 1 to the power of 3 over 2, but we know that's just going to be 1. And then this is basically my answer. Let me just double check that with the work. Uh-huh. Um, oh, okay, I see what happened there. Okay. Then okay. I'm just double checking because I did a step before, but I didn't because I wrote the answer as 16.6, but I think I was just in a hurry and I typed it in the calculator without just doing the full version. So I'm just going to quickly check that the answer is 16.6. Hold on. Do that. Minus 1. Yeah. Okay. So I get 15.597. So that would be 16.6. So that's correct. Okay, we're good. All right, number 2. A 3-meter rod lies on the x-axis. Its linear density is rho is equal to 2 plus k kilograms per meter. Find its mass. So the mass is defined as that integral from a to b of okay, I don't even remember. Let me just go ahead and pull it out. It is just the row function itself. Dx. I'm actually gonna, since I have it here, I'm gonna print out all of these. This one is 0 to r 2 pi x row of x. And this one is work, which is the integral from a to b of, I think it was just f of x plain Jane. Let me just double check in case I'm wrong. Yeah, f of x dx. Okay. All right, let's go ahead and plug this all in. We see that rho is just 2 plus x, and then we're figuring it out as a 3-meter rod, so we just need to do a distance of 3 meters. That's going to be easily done with 0 and 3. So 2 plus x dx. I'm just going to do the integral of that all together. We have 2x plus x squared over 2 from 3 to 0. I'm going to take advantage of the 0 canceling those out, or zeroing those out, not canceling. So just using 3 to get 6 plus 9 over 2. If I had to combine these, I would do 12 plus 9 over 2. So that's 21 over 2. Alright, and that's the answer for those. Let's do 3. A circular disc of a diameter of 8 centimeters has a radical density of rho of 10 grams per centimeter. Find its mass. Okay. So this really isn't necessarily a function of x. It's, even though with that variable, it's just going to go ahead and be a constant. So we're just going to go ahead and plug in the constant while also plugging in the diameter. Well, not diameter because it's radius. So we know the radius is half the diameter. So our version of this is 0 to 4. I'll put the 2 pi in the front. Actually, I'll put the 10 in the front to make it 20 x. So we have 20 pi from x squared over 2. 4 to 0, I'll let the 2 escape. So it's just, or the half escape to be 10 pi x squared 4 0. And then we're going to go ahead and do the 4. So the answer should be 160 pi. All right. Last one. A force f of x is equal to 10x squared newtons. Acts on an object moving from 1 to 3. Find the work. Okay, so that one's just kind of plain Jane. It's the least intensive. Well, this one's probably just as much intensive as this, but we can still do it. We got 1 to 3, 10x squared dx. Let the 10 escape. Oh, sorry, I was skipping ahead. Okay. So that's going to be 10 bracket x to the power of 3 over 3, 3 to 1. Here, I don't get the luxury of just letting it plug in, so I have to go ahead and do this. We have a 10 parentheses, and then for 3, that's going to be 27 divided by 3, which is just 9. And then we know 1, we'll just make that minus 1 over 3. From here, we can go ahead and make that into one fraction. We got 9 times 3 minus 1 over 3. So 27 minus 126, and then times 10, so 260 over 3. Oh, joules for this one, right? Okay. All right, that's pretty much it for this side of the group work. Let's go ahead and do 2.5. Now, 2.5, I liked it. It's a little fun. Um, This is a friend of mine, Professor Aniceto, was found dead in her office. Here are the coroner's measurements and the people she interacted with. Use this information to find the killer. Give me a second, I sneezed. Okay. It says, hint, you will use Newton's law of cooling twice with two different reference times. Step 1. Use the first and second corners measurements to find K. So these guys state that the first measurement, T of 0, is equal to 30 degrees at 1 p.m. And then T of 20 is equal to 28 degrees at 1:20 p.m. So 20 minutes pass. So we can try to fill this in as much as possible for step 1. Here for this, I'm going to go ahead and color code. So step 1, T of T is equal to T of the room, which is 20, plus T 0, which we say is 30, minus the 20, e to the kt. That gets simplified to 10. And then we are also told for the second measurement that when T is 20, T of 20 is 28 degrees Celsius. So we can go and solve for that. For T20, subtract to get 8 is equal to 10 E20K. Divide by the 10 to get I'll leave as a fraction. 0.8 is equal, I won't leave as a fraction. 0.8 20K to ln, and then divide by 20. Right, so that would be our K. Now, granted, this is when we found the body, but we know that K would be a rate that stays consistent throughout. So that's where step 2 comes in, and that's where we're going to play a little bit of a detective. Step 2 says, well, let's go ahead and adjust T0 to be 37, since that's, well, 37 to represent normal body temperature. So the room's 20, but we're going to do now 17, or I'll go ahead and do it in full, 37 minus 20. E to the 1 over 20 ln of 0.8 T. I'm going to go ahead and do two simplifications first. This 37 minus 20 is just going to be 17. And then this should simplify to 0.8 to the power of T over 20. Okay. Now it says using the value K, you found step 1, determine how much time passes until the body reaches 30 degrees Celsius. So we want to find out the time, based on this math, the time that Professor Aniceto was murdered. So let's go ahead and do that. So T is equal to 30 plus T. So 30 is equal to 20 plus 17 times 0.8 T over 20. Subtract by 20 to get 10 is equal to 17 times 0.8 T over 20. Divide by 17 to get 10 over 17. So you get a 0.8 T over 20. Take the log of base 0.8 to get T over 20, and then multiply by 20. And then I need to type this all into the calculator. Let's see. Times log of 10 over 17 by log of 0.8. So this tells me that 47.56 minutes have passed since they found the body at, let's say, at this initial point here. So that means that if we claim that the body, right, we say the initial temperature is 37, that means it took 47 minutes for it to go down to 30. And the body was 30 degrees at 1 p.m. So what is the time from 1 p.m. 47 minutes ago? So that would be I'm gonna round just because it's gonna be a bit annoying to do decimals. Let's round to 48 minutes. So 48 minutes before 1 would be 12 p.m. So 12 p.m. Who interacted with the professor at 12 p.m.? It says here that the teaching assistant interacted with the professor. So therefore, the teaching assistant was the murderer. Your test probably won't have like an elaborate story like this, but it's just a little fun sort of break from it all. Okay, almost done. We just need to do one more question just to make sure we have this wrapped up. A cup of coffee at 120 degrees Celsius is placed in a room at 20 degrees Celsius. After 4 minutes, the temperature is 80 degrees. Find the temperature after 10 minutes. Now, keep in mind that even though this is a cup of coffee, it could be a different cup of coffee. It could be the different mug, the different type, whatever. So we can't just use the same K like what we did before. So we have to pretend, even if it were to be the same K, that it's a new K. So let's go ahead and, sorry, I'm just checking my solution. Um, write this out. Okay. Okay, I want to use a different color. Okay. So just recall the temperature for Newton's law of cooling. T room plus T initial minus T room, e to the kt. And we know that for this problem, it specifically will be, room will be 20, and then initial minus room will be 100 EKT. And then we're told after 4 minutes, the temperature is 80. So when you solve for K, so 80 is equal to 20 plus 100 EK 4. Subtract the 20 to get 60, 100, E4K, divided by 100 to get 0.6, E4K, ln of 0.6, 4K, and then divide by 4. Then this guy can simplify using this into T of T is equal to 20 plus 100 times 0.6 to the power of T over 4. And I already did the simplifying. So now it says find the temperature after 10 minutes. So that means we're just going to type into the calculator this full expression, 10 over 4. Right? 20 plus 100 times 0.6 to the power of 10 over 4. And I get 47.89 as my rounded temperature. Rounded to 2,000 places. And that's it. So hopefully your answers matched. If they didn't, try to see what I did and try to learn from that. If you still need my help, no qualms, just let me know as soon as you have the potential to clock that you need the help. All right, that's gonna wrap it up, guys. Please do. Oh, so quick announcement. On the schedule, I accidentally overstepped. I did 2.3 yesterday when it was supposed to be done today. So I extended that homework, but then I also, because I posted a review, decided to, just for this week, not give you any homework so you can do the review. The review does not come with the video. The Schedule does not allot for it, so keep that in mind, okay? When you see it on the schedule that there's a review, that's when the video will be included. So keep that in mind. Yeah, if you have any questions, reach out. All right. Good luck with the test tomorrow, guys. Look out for that announcement at 7:30, okay? Bye-bye. Bye-bye.